In 1945, the science fiction writer Arthur C. Clarke first explored the idea that satellites could be used for broadcasting. Using Kepler's laws of planetary motion and Newtonian mechanics, Clarke's paper gave the exact conditions for putting a satellite into geostationary orbit. Today, there are hundreds of such satellites orbiting the Earth, and SES Global's operating companies and partner companies around the world operate over 40 of them. They provide audiovisual entertainment and information, broadband data and telecommunications services to an area that is home to 95% of the world's population. So how does the geostationary orbit work? A body of any sort orbiting the Earth, one such as our Moon, for example, stays in permanent orbit when the gravitational forces attracting it to the planet are balanced by the centrifugal forces generated by its speed of travel around the Earth that tend to send it flying outwards. The speed at which a satellite needs to travel for these forces to be in balance depends on its distance from the planet. Near the Earth, where the gravitational attraction is greater, its speed would have to be very high, and anyone wanting to receive signals from the satellite might only be able to do so for a couple of minutes at a time. In the same orbit as our Moon, they'd be able to see the satellite for about 10 hours a day, but in either case they would need a reception dish which constantly tracked the moving satellite across the sky. But at 36,000 kilometers above the equator, about 1/10 of the way to the Moon, and with a speed of 13,000 kilometers an hour, a satellite will stay in orbit at the same point or orbital position over the Earth as it rotates. And that means that viewers on the ground can pick up signals 24 hours a day, 365 days a year, from a fixed reception dish.